All right, today we're tackling a really big question, one that gets right to the very heart of what science is. When scientists figure something out, are they discovering a secret the universe has been hiding, or are they inventing the whole thing from scratch? You know, this puzzle was perfectly captured by the physicist Eugene Wigner. He talked about the, get this, unreasonable effectiveness of mathematics. What he meant was, it's kind of spooky how well math describes the real world, right? It just works almost too well. It's like we stumbled upon a secret code that was just lying there, waiting for us to find it. But here's the thought. What if that whole mystery isn't really a mystery at all? What if this entire centuries-long debate boils down to us just using the wrong word? Yeah, just one single word. So let's really dig into that idea. Okay, so the problem, according to the argument we're exploring today, starts with that very word, discovery. Think about it. When we say a detective discovers a clue, we mean the clue already existed, right? It was just sitting there, waiting to be found. But does science actually work that way? Is it really that simple? And that brings us to this really key distinction. On one hand, you have discovery, which is passive. It's like finding a finished blueprint for a house that someone else already designed. But on the other hand, you have construction. And that's an active process. It's about being the architect, the one who actually draws the blueprint, who builds the entire framework of our knowledge from the ground up.
So if we were really discovering things, that would imply there's some kind of ultimate truth out there, right? A complete machinery description, a final definitive rulebook for how reality works at the most fundamental level. But here's the thing, we don't have that. We are not even remotely close to having it.
And that right there is the absolute core of the problem with the whole discovery idea. Let's go back to that house analogy. If you have no idea what the final house is supposed to look like, how could you ever know for sure that you've found the real original blueprint? You just can't. The only blueprint you can possibly work from is one you draw yourself. So if a scientist isn't an explorer finding lost lands, then what are they? Well, this brings us to a much more powerful way of looking at it. Think of scientists as architects of reason. And this is such a great way to picture it. Science isn't about stumbling upon some pre-built house in the middle of a forest. No, it's about painstakingly designing and building that house, brick by brick, from the ground up. And look, this isn't some random, chaotic process. It's a very methodical, three-stage construction. First, you have to make distinctions. You have to draw lines in the sand and create categories, right? You decide this is a particle and that is a wave. Then you have to formulate assumptions. These are the rules for how your categories get to interact with each other. And finally, you build your theoretical model, the whole formal framework that grows out of those rules. It's a process that is 100% human-driven. Okay, but is there any real proof for this construction idea, like a smoking gun? Well, the argument is that there is, and it all comes down to a fundamental mismatch, a crack, between the tools we use to describe reality and, well, reality itself. So let's break this down. Premise number one. All of our scientific descriptions, we're talking math, physics, the whole shebang, are made of discrete, separate parts. Just think about it. Numbers are separate. 1, 2, 3. Categories are separate. Electron, proton, neutron. They're like individual Lego bricks we use to build our model. Okay, so that's premise one. Now for premise two. Reality itself doesn't seem to be made of those separate Lego bricks at all. I mean, the world around us flows, doesn't it? It's smooth, it's seamless, it's continuous. And our blocky, discrete tools have always struggled to capture that perfectly. I mean, think all the way back to Zeno's paradox, that old thought experiment where you can never quite get to the wall because you keep halving the distance. That's our discrete math creating a problem that just doesn't exist in the real continuous world. So when you put those two premises together, you get to a pretty powerful deduction. If our tools, our building blocks, are discrete, but reality is continuous, then reality can't actually be made of the discrete things we invented to describe it. It's like that old saying, the map is not the territory. Our amazing, detailed Lego model of a river, well, it's still just a model. It's never going to be the actual flowing water. And this all leads to a really profound conclusion. If our scientific theories are built using tools that we know don't perfectly mirror the universe, then those theories can't be simple discoveries. They have to be something else. They have to be inventions. Man, and this quote just says it all, doesn't it? We built the blueprint of a house. We did not find the house standing. It so perfectly illustrates this entire way of thinking. We are the architects. We created the plan that allows the house to be built and understood in the first place. So why does any of this matter? What's the big takeaway? Well, for one, it completely dissolves that mystery that Wigner was talking about. Of course math is effective. We invented it specifically to work with the other concepts we invented. It also completely recasts the scientist, not as some passive note-taker, but as an active creative force. Science, in this view, isn't a passive recording of the universe. It is one of humanity's absolute greatest inventions.
And that leaves us with a pretty incredible final thought, doesn't it? If science is truly our greatest invention, it makes you wonder, what are we going to invent next?